Aspirin, which is chemically known as acetylsalicylic acid, is a type of non-steroidal anti-inflammatory drug which is used to treat mild pain, inflammation, or arthritis. To make it, I start by adding 10 grams of salicylic acid to a round bottom flask, followed by 7 milliliters of acetic anhydride. I made the acetic anhydride in a previous video, so if you want to check it out, the link is in the description. I then add a stir bar and turn on my heating mantle to 60 degrees Celsius. I slowly add a few drops of concentrated phosphoric acid as a catalyst. Sulfuric acid works just as well, but I prefer phosphoric acid since it's less scary. Soon after the addition of the phosphoric acid, the salicylic acid starts disappearing as it reacts with the acetic anhydride to form our aspirin, which dissolves into the acetic acid thus formed. Once there's no more visible salicylic acid left, I let it stir for another 15 minutes. I then dump it into some cold water to make the aspirin precipitate. Unfortunately, nothing crystallizes out. This is actually because the excess acetic anhydride that was in the mixture is preventing the aspirin from crystallizing. To make the aspirin crystallize, we need to stir it for a few minutes until all the acetic anhydride has hydrolyzed in the water to form acetic acid, allowing the aspirin to crystallize. After a few minutes, you can see that the solution became cloudy due to aspirin precipitating out. You can actually see some aspirin chunks at the bottom of the beaker. I then pass the solution through a coffee filter to isolate the aspirin. I also wash the beaker and the aspirin with some cold water to clean it up. After the aspirin dried, I recrystallized it from some ethanol, and the final yield came out to be 6 grams. I unfortunately lost the footage of the recrystallization, so you're not able to see it in the video. Anyways, the yield is pretty bad, likely because under these conditions, salicylic acid tends to react with itself to form phenyl salicylate via an acid-catalyzed esterification. Under harsher conditions, the salicylic acid can also cyclize to form xanthone derivatives. However, this requires more harsh conditions, and it probably didn't happen here. Anyways, to test the purity of my acetylsalicylic acid, I'm going to be doing something called the ferric chloride test. To do this, I dissolve some of my powder into some hot water, and then add a few drops of dilute ferric chloride solution. As you can see, the solution turns purple. This is unfortunate because it means that there's still some salicylic acid contamination in my aspirin. The purple color comes from a complex that the ferric chloride makes with open phenol groups. Aspirin, however, doesn't have an open phenol group, so it won't make a complex. However, it turns out that even some medical-grade aspirins still contain some salicylic acid, so this test really doesn't help confirm if my aspirin is pure enough for medical purposes. Anyways, I hope you found the video interesting, and I'll see you in the next one.